4.1 Antiderivatives and indefinite integration. An antiderivative is a differentiable function capital F whose derivative is equal to the original function lowercase f. When solving a differential equation of the form dy dx equals f of x, it's convenient to write it in the equivalent differentiable form dy equals f of x dx. The operation of finding all solutions of this equation is called antidifferentiation, or indefinite integration, and is denoted by an integral sign, which is the curvy L. This is how you will see most of your problems on tests and quizzes. F of x is called the integrand, capital F of x is the antiderivative of the original function, dx is the variable of integration, and c is the constant of integration. These are a couple rules you'll need to know for the future. The first one is called the constant multiple rule, where you have a number in the front, you can take it outside. And the second is called the power rule. When you have an exponent, n, you add one and then divide by the new number. And then the third one is when you're integrating a single number k, you just simply add an x. And the following are just trig functions that will need to be memorized. These are cosine x dx equals sine x plus c, sine x dx equals negative cosine x plus c, secant squared x dx equals tan x plus c, secant x tan x dx equals secant x plus c, cosecant squared x dx equals negative cotangent x plus c, and lastly cosecant x cotangent x dx equals negative cosecant x plus c. Example number 1. Integrate 3x dx. First, I follow the constant multiple rule and I take the 3 outside the integral, and I have x dx left. Technically, it's x to the first, so 1 plus 1, x squared, divided by 1 plus 1, which is 2. Which gives me my final answer, 3x squared divided by 2. Another example, integrate x plus 2 dx. First, I split it up, so I got the integration of x dx plus the integration of 2 dx. X squared divided by 2 was for x, and 2x was for 2, and then I just added the constant of integration for my final answer. Integrate 8x to the 7th dx. So you add 1 to the exponent to get 8 and divide by 8. 8's cancel out, it's just x to the 8th plus c. Lastly, integrate x to the 5th dx. Add 1 to 5 to get 6 and then divide by 6. X to the 6th divided by 6 plus c. A harder example is to integrate x plus 1 divided by the square root of x dx. First, you split them up, so x divided by the square root of x plus 1 divided by the square root of x. Then you rewrite with fractional exponents to get x to the 1/2 plus x to the negative 1/2 dx. Then you integrate, so n plus 1, so 1/2 plus 1 is 3 divided by 2, and then you divide by that same number. Same thing for negative 1/2. Negative 1/2 plus 1 is 1/2 divided by 1/2 plus c. Then I simplified to get my final answer, 2/3 x to the 3 divided by 2 plus 2x to the 1/2 plus c. If you have a T184 calculator, a tip I have for when there's upper and lower limits is to go on Math, scroll all the way down to number 9, FNINT, press enter, and you have integral on your calculator.
Created using Powtoon.